Hello everybody, welcome to iTTV. My name is Mr. Joel, your tutor for this lesson. Alright guys, we are at a new chapter. Alright, and this chapter is called variations. Alright, before we go into the details, variations are very important because they are used in our everyday lives. Take for example, petrol. The price of petrol is proportionate with the amount one pays. So most cases in our lives actually is a variation between two variables. Alright, so let us see what we are going to look at in this lesson. Variations. A variation displays the changes in the relationship between two variables. So this, guys, is the definition of a variation. Simply take any two variables or any two quantities. When there is a pattern of change between one variable and another variable, it is called a variation. Now, I'm going to show you a few specific examples of how variations can occur in our daily lives. Take a look at this picture. I'm sure all of you know, right? The speed of a car increases when you step the accelerator harder. So now, what are the two quantities here? First of all, speed, right, is one. What is the second one? The amount of press on the accelerator. The more you press the accelerator, the higher your speed. So can you see that both of them vary and there is a change? Take a look at the next picture. The harder you blow a balloon, the bigger it gets. So guys, when you take note of sentences like this, variations occur, right? The harder you blow a balloon, the bigger it gets. So there are two quantities here. First of all, the size of the balloon. Next is how much pressure of air that you blow inside the balloon. So remember, two quantities or two variables. What about this? For the salesperson, the more items sold, the more money he earns. Alright guys, welcome to the world of sales, right? What are the two quantities here? First of all, items, right? The more items a salesperson sells, the more amount of commission he gets. So remember the two quantities here, sales of items, and then next, the more money he gets. Alright, and do we have one more? To build a bridge in a short time, more workers are required. Alright, if you take a note carefully here, it is very simple, right? To complete a task of building a bridge, the more workers you have, the less the time is required to complete the whole construction job. So guys, all these four specific examples shows you a very simple pattern of variations that occur between any two variables. The variables can be anything that occur in your daily lives. For example, speed, temperature, alright, the more items, money, and so on. So we are going to look specifically at a few kinds of variations that will occur in this chapter. Now, let's take a look at the types of variation. There are three types of variations involving variables. They are 1. Direct variation, 2. Inverse variation, and 3. Joint variation. So guys, there are only three kinds of variations and we're going to look at them one by one. Alright, so let's start with the first kind of variation, which is called direct variation. Example. The wages of Matthew obtained are directly proportional to the number of hours he works per week. In other words, the more hours Matthew works, the more money he earns. Alright guys, a very simple example, right? How many want you to learn more? If you want to earn more, you work less. No, right? The more you earn, the more you work. So now, this is an example of direct variation. Now, if Matthew works 36 hours in a week, he earns $540. What are his wages if he works 40 hours in a week? In this situation, the variables involved are 1. number of hours Matthew works, alright, let it be H. 2, wages that Matthew gets, let it be W. When the number of hours Matthew works increases, wages he gets will also increase. When the number of hours Matthew works decreases, wages he gets will also decrease. So guys, a very simple example. The more Matthew works, the more money he earns. The less he works, the less he earns. So remember, when you see anything, always try to identify the two variables that are involved, alright? So direct variation is very simple. One quantity increases, the other increases. One quantity decreases, the other decreases as well. So that is the pattern. Now, this is an example of direct variation. We can write the relationship between wages and number of hours Matthew works as W, variation symbol with H. In equation form, W equals KH. Alright, now, constant of proportionality or K. All the variations we have seen are related by a constant of proportionality or K. That means if two quantities are proportional, they have a constant ratio. Example, when y varies directly as x, the ratio of y over x equals k, and therefore y equals kx. When the relationship y over x does not equal to k, the quantity y does not vary directly as x. Direct variation, y equals kx, or y over x equals k. Not direct variation, y over x does not give you k. Alright guys, this is the most important property regarding direct variation. I'm going to demonstrate to you one more time this same fact on the board. Alright guys, remember, direct variation now will occur between any two quantities. Alright, so let's take y and x for example, alright? And y and x can represent any two variables. So, if y varies directly as x, alright, now remember, the pattern is set. Direct variation has arrived. So, in this chapter, there is a symbol for variation. And the symbol is this, alright? So you can actually liken it to the symbol of a fish. Alright, so remember guys, direct variation, this is the symbol. So if you forget, just remind yourself that it looks like a fish. Alright, so now, if y varies directly as x, we write it in variation form as y, variation symbol or the fish symbol, varies directly as x. So when you see this kind of thing, you know that y varies directly as x. Alright, and you can actually write it in an equation form. If you take off the variation symbol and you replace it with an equal sign, alright, then something you must also include, which is k. K is the constant of proportionality which we have learned just now. So this is the variation form, and this is the equation form for two variables y and x that vary directly as one another. Remember direct variation, y increases, x will also increase. Y decreases, x will also decrease. So that means direct variation. Alright, let's take a look at this example. The table below shows the relation of the weight, y mass, of Mr. Dowell aged x years. Determine whether y varies directly as x. Alright, let's take a look at the table. X represents the years or the age of Mr. Dowell. So, and y is mass. So you can take a look at their respective pairs, right? When x is 10, y is 40, x 20, 70. As the age increased 30, weight also becomes 75, 40, 79, 50, 80, 60, 75, 70, 75 also. Alright guys, when you take a look at this kind of pattern, doesn't mean that when one increases, and the other also increase, there is direct variation, because you must confirm or verify it by using the value of K. And what is K? The constant of proportion. Alright, so now, does Y vary directly as X? Solution. So X and Y, the two rows, add another row. Because remember, if Y varies directly as X, Y fish X. Remember, if you change it to equation, Y equals to KX. It means that K is Y over X. So now, build another extra row and take all the values of Y and divide it with the values of X correspondingly. So the first one is 4, 3.5, 2.5, 1.975, 1.6, 1.25 and 1.071. So the value of Y over X, which is K, for all the values of X and Y are not equal. In other words, they are not a constant. So what conclusion can you make from this? Y does not vary directly as X because Y over X is not a constant. So if you want to check whether two quantities vary directly one as another, check the value of K by first of all determining how that variation works. Alright guys, let's move on. Now let's consider the following data set. Alright guys, take a look at this table and all the values of X and Y. Alright, when X is 1, Y is 1. When X is 2, Y is 4. When X is 3, Y is 9. When X is 4, Y is 16. When X is 5, Y is 25. So now guys, can you see that 2 times 2 equals 2 square, which gives you 4. 3 times 3 equals 3 square, which gives you 9. And 16, 4 times 4 equals 4 square, and the pattern goes on. So can you see that there is a pattern between Y and the value of X? Y is actually the square of X. So what can we make of this pattern? What is the pattern of relationship between X and Y? Alright, we have Y equals X squared, right? So it's very important to know how to represent the relationship between Y and various functions of X. So we can have many kinds of functions. In equation form, K represents constant. So now let's take a look at 4 relations. First of all, Y varies directly as X. Symbol form, Y vary X. Equation form, remember, just put an equal sign and include K, alright, in front of the X. Now, second one, Y varies directly as X squared. Symbol form, Y varies X squared. Those are the two quantities. Equation form, take out the symbol, put in an equal sign, and don't forget to include K. Y varies directly as X cubed. Variation form, symbol form, Y vary X cubed. Equation form, Y equals K X cubed. Remember, equation must always put the equal sign. And lastly, Y varies directly as square root of X. Symbol form or variation form is Y varies as square root X. Equation form, Y equals K square root X. So guys, remember the two quantities now is not limited to just Y and X. It can be Y and X cubed, Y and X squared, Y and square root X, and so on. Just remember that direct variation always involves two variables only. And the most important thing is to write it in the symbol form, change it to equation form, and identify the value of K, because the constant will always be equal when there is direct variation between any two variables. Example, P varies directly as the square root of Q. What is the relationship between P and Q? Is it A, P vary Q? Is it B, P vary Q square? C, P varies Q power of half? Or D, P varies Q to the power of -2. Alright guys, remember this is an objective question, and let's read again. Remember what kind of variation? It tells you there, varies directly as the square root of q. Alright, so full stop. When p increases, the square root of q will also increases and vice versa. So which of these four is the right symbol form? Remember symbol form? It must have that fish symbol over there because it's not equation form. So let's take a look at the solution. Square root means to the power of half. Square of x equals x power of 2, right? Square root of x equals x power of half, or square root x. So now, the two quantities are p and q to the power of half. So the answer is C, because that is the correct symbol form. P varies directly as the square root of q. Alright, next example. It is given that A varies directly as the cube of B. What is the relationship between A and B? Alright guys, can you try this yourself? Is it A varies 3B, B, A varies B cube, C, A varies B to the power of negative 3, or D, A varies 1 over B cube? Alright, I'll give you 1 second, alright? Can you try and determine which is the answer? Alright guys, the answer is B, because the two quantities are A and B cubed, right? So varies directly means A varies B cube, and the variation symbol, which is like a fish, must be there also. Alright, next example. Given that y varies directly as x and y equals negative 1 when x equals negative 3, express y in terms of x. Alright guys, this is a direct variation question. Let's move on to the board. I'll show you the solution for this question. Alright guys, let's read again. I've managed to simplify the question. Y varies directly as x. So you know that this is my quantity. Y is my first quantity. X is my second quantity. So remember, y varies directly as x. First of all, you must always start off with writing the two variables with the symbol form. Y varies directly as x. Remember early on? Alright, so y fish x, something like that, alright? So y varies directly as x. Alright, let's continue. Y equals negative 1 when x equals minus 3. Express y in terms of x. Alright guys, make sure you identify what does it mean by expressing y in terms of x. This means that you must form an equation of y involving x. So remember, this is a hint for you actually to change from variation form or symbol form to an equation form. So remember just now, early on, move back. When y is changed into equation form, equation symbol comes into place and there is the value of k. And what is k? The constant of proportionality. Alright, so now the equation is not complete if we do not know the value of k. So how are we going to find the value of k? A pair of values will always be given. When y is negative 1, x is negative 3. So substitute those values inside the equation now. When y is negative 1, x is negative 3. And k will be negative 1 over negative 3, or 1/3. Right? And lastly, don't forget, because the question wants you to get the equation, right, of y in terms of x or y in terms of x. So substitute back this value of k that you have obtained into the equation and rewrite the whole equation involving y and x. So y equals 1/3 x. And this is expressing y in terms of x. So remember guys, always the constant or variation of k will always be different, right? For any two direct variation, it's important to find out what is that value of k. Alright, next example. Given that p is directly proportional to n squared, and p equals negative 18 when n equals to 3, express p in terms of n. Is it A, P equals 3n square, B, P equals negative 2n square, C, P equals n square over 2, or D, P equals to 1/3 n square? Alright guys, a similar type of question, alright, like the previous one. So now, remember first, analyze that question carefully. What can you make of it? Alright, the solution. First of all, write it in symbol form. So P, it is given, varies directly as n square, and then change it to equation form. P equals kn square. Don't forget to put k, alright, because k must always be there. And then find out the value of k by substituting the given pairs of values. When n is 3 and p equals negative 18, negative 18 equals k 3 square. Negative 18 equals 9k, k equals negative 18 over 9, k equals negative 2, and therefore p equals negative 2n square. And your answer should be B. Alright, so remember the steps, alright, especially involving direct variation. Alright, next, given that y equals to k square root x and y equals 15 when square root x equals 5, find the value of y when x equals 4. Is it A, 2, B, 4, C, 6, or D, 12? Alright guys, remember, what do you want? You want the value of y when x equals 4. Alright, so remember the steps early on, alright? Let me show you again on the board. Alright, let's take a look here. Given that y equals to k square root x, y is 15 when square root x is 5, find y when x equals 4. So always remember the pattern of solution is always the same for direct variation. First of all, y equals to k square root x. Can you see that actually this has already been written for you? Because this is actually the equation form. What are the two symbols now, or the two variables? Y and square root x. This means that originally it is just y varies directly as the square root of x, alright? So remember, both forms are equal. They are just different kind of forms. So now, find y when x equals to 4. So before we can find y, you must find k first. Okay, because the constant of proportionality must always be found first. And how do you find it? They will always give you a pair of values. When y is 15, so I substitute y 15, square root of x is 5, means this whole thing is 5. So we can see that actually k is 15 over 5, which gives you 3. Alright, remember we are not answering the question yet, because don't forget that this value of k must be put back inside the original equation to complete the equation. So therefore, y equals to 3 square root x. Alright, now let's answer the question. Find y when x equals to 4. So when x equals to 4, substitute 4 and put it inside. And the square root of 4 is actually 2. 3 multiplied by 2, the value of y is actually 6. So guys, remember, when you are asked to find the value of one variable given another variable, you must always start with the same way. Alright, remember, write in symbol form, change to equation form, find the value of k, complete the equation, then substitute. Alright, it is always the same 3 or 4 steps. So the answer is C, 6. Alright, now, next example, the variables x and y are related by the equation y equals h, x minus 2 square, where h is a constant. Pairs of corresponding values are given in the following table. So x 5, y negative 18, x negative k, y negative 50. Calculate the positive value of k. Is it A, negative 7, B, negative 5, C, 5, or D, 7? Alright guys, can you try this by yourself? All right, let's take a look at the solution, all right? So first of all, right, y equals h x minus 2 square, minus 18 equals h 5 minus 2 square, negative 18 equals h 3 square, negative 18 equals to h 9, h equals negative 18 over 9, therefore y equals negative 2 x minus 2 square, negative 50 equals negative 2 x minus 2 square. So x minus 2 square equals negative 50 over negative 2 equals to 25, and then x minus 2 equals square root of 25, h equals negative 2, and x negative 2 equals 5, the value of x equals 7. So a similar kind of example. Remember the 3 or 4 steps. So the solution is D, 7. Alright, let's move on to our last example. Alright, so let's take a look at this kind of problem. The surface area of a sphere varies directly as the square of its radius. What is the change in the surface area if the radius is doubled? Alright guys, we have a problem here, alright? So take a look, what are the two quantities first, alright? Because direct variation has already been told. First of all, a sphere, and the surface area is the first quantity. It varies directly as the square of its radius. It means when the area increases, the square of the radius will also increase, and vice versa. Alright, so now what do you want? Is the change in the surface area if the radius is doubled. So what happens when the radius is doubled at any point of time? So let's take a look at the solution. So since the surface area of a sphere is given by the formula A equals to 4 pi r square. Alright, when its radius is doubled, A equals to 4 pi, change r to become 2r square. So A equals to 4 pi, 4r square. A equals 16 pi r square. Change in the surface area when radius of the sphere is doubled equals new surface area over original surface area. The difference means minus. Change means looking for ratio. So don't forget that, alright? So equals 16 pi r square over 4 pi r square 4 times. Alright guys, let us take a quick review of what we have learned today. Alright, first of all, determine whether a quantity varies directly as another quantity. Alright, how are you going to check that? By using the value of the constant of proportionality, which is called K. So don't forget, if you get a set of values, the K must be the same, then only you can confirm that direct variation occurs. 2. Write the relationship between two variables in equation form, don't forget. And then 3, understand that if y varies directly as x, then very importantly, y variation symbol x. In equation form, y equals kx, where k is a constant. Therefore, k equals y over x. So guys, that is the end of this lesson. Alright, in the next lesson, we'll be looking at the second type of variation. So I'll see you in the next lesson. It's goodbye for now.